Hi everyone, my name is Jagjit, and for this weekend hackathon, I picked the data health aggregator. My inspiration behind this product was because there is so much fragmented data that is sitting on our wearable tech, and we do not have a single unified view that gives us an overview of all this data, and we have to manually correlate this data all the time, which gets really hard. Let's talk about some current health data care challenges. I can explain this with an example since my sister is from a microbiome domain and she's getting her PhD in it. And she always tells me there is so much data, healthcare data that is sitting, but there is always technical barriers or missed insights from incomplete data, which always causes delayed decisions. So what is the solution that I have built is a full stack health analysis platform that has a unified data ingestion, AI-powered anomaly detection, RAG enhancements, and real-time monitoring. This is the overview of our system architecture where we're using front end for front end React and Next.js, for API layer using fast API, and for service logic, we're using AI ML processing. And then finally, we're using data for databases, we're using PostSQL and PG Vector for storing embeddings. This is the technical stack details. Since already discussed for front end Next.js, back end Fast API, for AI ML, we're using OpenAI embeddings to create embeddings to provide it to the RAG system, and then GPT-4 Mini for conversational purposes, and PG Vector for storing the vector, storing the embeddings. And then finally, for infrastructure, I'm using Docker and PostgreSQL. This is the data pipeline architecture where in stage one, the data ingestion occurs. This is a simple ETL pipeline that uses that can ingest data from various sources such as APIs, but we're using a simple data set. Uh, so in stage two, the validation and transformation occur where the data cleaning is done. And in stage three, the feature extraction happens. And in stage four, the processing and analysis happen. And finally, in stage five, we optimize the indexes for the rack system. And then for anomaly detection, we're using simple z-score analysis, baseline statistics, and processing methods. And also for daily aggregations, we're using simple SQL functions to find sum averages, min, max for the ranges. And for AI ML architecture, I'm using retrieval augmented generation pipeline using OpenAI embeddings and to provide a semantic search using PG vector. And then since then we are providing document embeddings for specialized for pattern recognition, and then also place some safety guardrails using prompts in the rack. Some of our core features are JW authentication, health source data ingestion, and daily metric aggregation, multi-domain and anomaly detection, AI-powered chat insights, RESTful API design, and it is a health analysis platform. For security and performance, using password hashing, which is a bcrypt auto salt implementation, and JWT security for password hashing, and then SQL injection prevention, uh, input validation, course configuration, and then optimized databases for high performance vector indexes. Finally, some of the benefits and impact that our platform uh, will make is to the individual users who actually uh, analyze their personal health data. This will help them track all the matrices at one place and then have a story of their data set. Also, healthcare providers and researchers can benefit from this because this is a unified platform where the data comes into one place. For these are some API design and endpoints that we are using to authenticate for AI chat interface, data source control, daily aggregation, and detection management. And then our database schema design looks like this, where we have health matrices, to data aggregates to actually uh, provide the single day view or weekly view for users. And then we have health documents that has rank embeddings that is provided as a context to the AI to decrease the hallucination. And then we have anomaly tables that actually finds the anomalies using simple ML models. Some of the future enhancements will be we can definitely increase the visualization and data export quality, and then use the native API integrations for support of all the variable tech. And then we can also work on some advanced analysis, such as correlation discovery, time lag analysis. And then for LLM security and AI safety, which is the most important aspect, we need to work on prompt injection defense, response validation, rate limiting, and research-backed intelligence, uh, which we can use such as PubMed articles or NIH integration to provide more insights on the nutrition data or any healthcare data. In order to be HIPAA compliant, we can use AWS Bedrock over OpenAI, because this is a healthcare app. They need to be HIPAA compliant. What this will help is that the user data will never be used to train the models. And then we can use some advanced AI agents for multi-turn conversations. Now we will look at the actual product. So this is the product that we have. We use a simple login. Once we are logged in, we are displayed with a dashboard that first tells us, that first shows the daily health insights. Since there is no data from today, we will look at the data from yesterday. So this actually tells me what what my day looked like, how many steps, calories, average, what was my average heart rate. But these are just numbers. So we wanted to get more insightful summary. This is where it provides a complete summary using my own actual personal data that I have been using. Then we can also switch to a weekly summary, where it gives me a complete weekly summary, such as this is what I need to do since uh, since my heart rate was kind of below average. And then it kind of gives all these insights to the user, which is very readable and helpful. Our next feature is it detects anomalies in data. So these are all the anomalies that is detected in the entire week. Uh, we can switch to the daily view and see all these anomalies that were detected. So now this health assistant can help us based on our own personal data to help us what happened, or if I want to know, since it detected an anomaly that I was a calorie deficient. So I can ask, suggest me by calorie on December 6th, and suggest me some foods to cover that gap. So now our health assistant will actually look into our own data and then give us the insights on our data. This is what we get. It gives us a complete answer on what we can do. It looked at the data, it is actual user data, and then this is what it is providing. Also, let's test some guardrails. Let us say I am asking some off-topic question. Dogs have ears. So it does not go off track. Or if I ask for some healthcare advice, please trade help me. See, it never answers. Or it also detect emergencies. Let's say I can say, I feel like uh, it actually provides those responses. Uh, so this is all we had. Thank you very much.